Hello everyone. This video is for beginners of PLC M241 EcoStruxure software. I hope that this may benefit for everyone who is watching, because I've suffered at the beginning for lack of resources in my case. So at the beginning I want to describe that for the PLC that I'm mentioning, TM241, there is a simulation mode. In that simulation mode, the user can simulate the logic before loading it to the PLC. This is the first information I want to deliver. It is well known for everyone, but the procedure is like this. You first go on the target device, PLC, and in offline mode, here you can see, you click simulation. Once simulation activated, you go online. It is similar to the normal connection mode of the PC with the PLC. It is look like you have direct connection with the PLC in the front of you while you don't have it. So now let's go step by step. For my case, I have two digital input cards with two analog output cards. My aim is to control 6 motors. Those motors are controlled by a frequency controller. So once I receive from the site, I have built some logic. The logic can be easily built by another sequence. For my case, I have built a logic of timers. Those timers will operate the motor in case if I have no signal received from the fire alarm system or CO detectors relating the threshold of the CO in the garage relating to the site. Those motors are installed in the basement of one of the residential compartments. In case the CO level goes high, in level 1, let's say, low, then the motors will operate in speed 1. Once the CO level rises above the threshold, then I will get another signal indicating that CO is high. In case I don't have both signals, low and high, CO low and CO high, I will run the motors in, let's say, air exchanging mode, which will be defined later on based on the client's requirement. We can define the motor's operation time and switching off. Let's say we can operate the motors 10 minutes within 2 hours, for instance. This is the case where I don't have any input from the sensors, CO sensors. Once I have fire, also by the way, I have HMI connected, so I have to drive all the input signals from the field or the terminal of the device, the inputs, which is coded by IX 1.1. You can see from here. Also the coding of the modules, input module 1.1, for instance, fire. We have to configure it and route it to the output of, let's say, we have to put it in memory. We have to write it to the memory, then we will be able to have it on the HMI. This is now the indicated memory. You can see here, the percentage indicates starting of the addressing. MX09 indicates the memory mapping for that signal, that individual signal. Now let's move on. Once I have COH low, or I want to start the motor from remote, I will run the motor, or I have a CH high. Another condition is pulse. The pulse is, as you mentioned earlier, the pulse will operate the motor, let's say, in a continuous manner to exchange air. So, for another case is about the operation of the analog output. As I told you, for a frequency controller, you need to have a reference signal. The reference signals will be an integer value. The integer value is relating to my analog output. So analog output module is here. The analog output came without any predefined configuration. So from my side, I will activate for 220 milliamp. Let's do the same for all outputs. So each output in my case connected to a individual motor. So minimum value will be from my side 0 to 20,000. This is 0 to 20,000, 0, 20,000. So when I send 0 to the specific output, then I will get 4 milliamp. When I send 20,000, I will get 20 milliamp. This is the idea behind. Let's move on. Okay, now we have all the outputs are being configured, analog outputs. I will make a double check at the site regarding the actually measured or injected milliamps to the outputs individual before connecting it to the controller, because our current sure will harm or in a severe case damage the input of the controller. So be assured that you send the correct signaling value to specific output. Now what I have here is the coding. The coding for the analog output is like this. For analog output 1 I have QW2. So what I'm doing is for model 1 I am routing the QW1 to QW2. So I have written here QW1, but practically let me change the name to QW2. So QW2 will be the address for QW2. This will be more clear. So whenever I add any specific output to output QW2, the value will be written here. So I will, to avoid confusion, I will remove any extra or duplicated variable. Now I have QW2 assigned with QW.2. I want to order the outputs with the sequential manner. I will just click on the top address here. So now I have QW3 and QW2. If I want to order relating to the name, then I will click it simply. So I have now QW2 and 3 have been assigned. You see QW2 to output analog 2, QW3 to output analog. Let's move on and continue preparing for the other motors. Now those two motors can be by using shift, click here, click another click here. Both will be highlighted and you can just make a copy. This is my old, by the way, old one. I will remove. My new configuration is like this. First of all, I will enable the selection block. The selection block will see whether the zone 2 CO is high or low. If the CO002 CO in zone 2 is high, then I switch to second value. If it is low, I will keep the motor running with low speed. This is high speed motor, this is low speed motor. So the integer value should be 10,000, let's say half, and 20,000 for full scale output. So 10,000, let's say 10,000 is the minimum, and say the mid speed, and 20,000 is the high speed. So I activated the select box continuously by an predefined Boolean variable. Once I run, this output will be active, the enable. Always I need to get enable input active high to be able to switch between the two inputs. So in the normal case, when I have no CO high signal arrive, I will send through the analog output the input 1, which is half speed analog output reference signal. By having that signal on the predefined location on the FC controller, I need to have also a start signal from either from the control panel mounted on the board, or let's say automatic, one of the two conditions, even the CO low active or CO high, or I need to operate periodically by the program timer. So one of these conditions need to be achieved to be able to run the motor, because the motor for the frequency controller is VLT F101. So for that specific frequency controller, you need to have analog input as a reference. In addition, you need to have a start command on point 12 and 20. I can show you. I will show quickly this one. First of all, I need to have a close command to be active on here. This one has been routed directly from the PLC. This is the input from PLC coming from the binary output. Exactly, I am mentioning this one. This binary output QX101 is the digital output source from the relay. Will activate this auxiliary relay. This auxiliary relay will enable starting. We have another input which need to be active always, which is the 27.07 on the frequency controller. This one is allowed to automatic on. So if you have a look to the manual, you will see that one continuously connected to the main positive reference from the frequency control side, and this command can be changed based on the user need. Can start up and stop by using this. But for emergency case, we have also a condition in this project. We have a case where the user can switch off the hands-on, let's say auto-on frequency controller by cutting this signal path. So it will be directly shut off. This is the idea. Let's go back to, so once I have a close command started and I have no emergency on the board itself, then the output signal will be routed to the analog input of the controller. Here you can see the common and analog input are a connection with the module, the analog output module. The analog output module here you can see from the output of the module is 4020. Don't forget to connect to the correct place, to the correct wiring. Secondly, you have to also change the reference signal inside the controller to be at 4 to 20 milliamp, not a voltage, because you have two options. First one by 4 to 20 milliamp. The second one is by using a reference voltage coming from external, let's say, resistor, variable resistor, something like this, to point number 54.